In this video, I am going to be covering section 3.3. We're going to spend a couple days on it, but the first day, we are going to focus on how to graph linear systems. Sorry, I'm going to zoom in here just a little bit. You can see the graphs a little bit better. Okay, there we go. All right, so we are going to graph the solution. It's going to show all possible solutions. Okay, so this is actually a system involving 3 linear equations. We can actually have infinitely many equations. Obviously, they get harder and harder to solve. So we are going to work with just 2 variable systems, but we're going to have more than 2 at times. So here, I am going to graph each of these lines. Again, I want my lines to be very accurate because I want to be able to find their intersections. Okay, so inequalities, as a reminder, we're going to graph the same way we did lines. Y-intercept is -1. Slope of that first one is -1, so I'm going to go down 1 over 1. And again, I'm going to keep my lines pretty accurate, so I'm going to kind of outline where it's going. Okay, so if you guys recall linear inequalities, we could have a dashed line or a solid line, and then I needed to shade above or below the line. So for this one, it is y is greater than or equal to, so I'm going to make my line a solid line. Okay, and then I am going to shade above since it is greater than. So I'm going to shade just really lightly here, you guys, because we want to find the solution for the system, which is where all of the shading is going to overlap. So I'm just going to shade really lightly, and then I'm going to shade dark where the overlap is. Okay, so now I'm going to graph this one. So I have y equals 2x plus 1. So here's my y-intercept, and then I'm going to go up 1, 2, and over 1, and I'm keeping that pattern going. Over 1, up 2, and over 1, and then down to left 1. Okay, so again, this one is a solid line, and this one would be shaded below since it's less than. So right now, if it were just these 2 lines, my solutions would be this section right here, where the overlapped shading piece is. Okay, but we have a third one. X is less than 1. So I know that's a vertical line at 1, and it's a dotted line. Okay. And x is less than 1 is everything to the left of that vertical line. Okay, and again, I shaded very lightly, so it's a little messy right now. So now I just need to analyze where are all 3 shaded parts overlapped. So initially I said, okay, it was here for the first 2. Now where did the x is less than 1 come into play? So the only place that overlaps here is in this region, kind of this triangular region. So anything on this line up to that point of intersection is a solution. Anything on this line up to that point of intersection is a solution. Anything on the x is less than 1 is not a solution. So basically this region, any point in here, is a solution to all 3 inequalities, is what that means. Okay? All right, let's try another one. So I have x is greater than 0. So 0 is the y-axis. Yep. Greater than is to the right, and again, I'm just going to go real light, trying to keep track of where is the overlap. Okay? Excuse me. Y is greater than 0, so this time it's a horizontal line through 0, and it's greater than or equal to, so again, it's solid. Greater than would be above. Okay, so far at quadrant 1, I'm overlapping both shaded areas, so we're kind of continually like narrowing down that shaded region. Okay, y is less than -2x plus 5, so y-intercept of 5, and then slope of -2. Let's see, -2. Okay, and it is greater than. So I'm going to do a dashed line. okay, and it's shaded above, so now overlap is still quadrant 1, but now not including this like triangle right by the origin, okay? And now I need to graph this one. Y is less than 3x plus 1, so 1, and then up 3 over 1, over 1. Okay, and this is going to be less than or equal to, so get one more point on here. So solid line, less than or equal to shading below, and again I care about where does it overlap those previous 3 solution regions, and that is all right here. So above the x-axis, less than the line I just drew to the right of the y-axis, and greater than my dashed line. So that whole area, any point in that region is a solution to all 4 inequalities. Okay. All right. So if we think about this, this is a compound inequality, you guys, which remember is an and. So one way I can think about it as a system is x is greater than or equal to -3 and x is less than 2. So if I want to graph this on a coordinate plane, just like the number line, actually I'm going to graph that on a number line real quick. So -3 up to 2, it's an open circle at 2, closed circle at 3, and it's everything in between. It's going to look pretty similar on this one actually, you guys. It's just 2-dimensional, it's involving y as well, instead of just the single x coordinate. So x is greater than or equal to -3. So that is a vertical line through -3, and it is solid. So closed circle, solid line. Less than 2, so vertical line through 2. Oh, sorry, but this one's got to be dashed. And then it is shaded between there. So everything on the 3 line is a solution up to the dotted line. Okay. This one we are given the solutions and asked to write a system. So I know it's going to look like this. The easiest way I think is to write it in slope-intercept form. So find the intercept and the slope. So I'm going to do the solid line first. So here, my y-intercept is 4. Start with y, and then my y-intercept is 4. Oh, sorry, I don't want equals, actually. We're going to come back to that. Okay, and then my slope is up 1 and over 3 to get to that point, so 1/3. Okay, so now the symbol, the shading is below that line, so it's got to be less than, and it's solid, so it's less than or equal to. All right, now the other equation is dashed. Okay, it's also shaded below that line where it would have to intersect, so it's going to be less than. Okay, my y-intercept I can't really see, so what I might do is use a different point. So I'm going to come back to that here in just a second. I can see the slope though, because this is a nice point and this is a nice point. So here, let's see, I go over 3 and down 1, 2, 3, 4, 5. So my slope is -5/3. So I know that. Now the y-intercept, all I have to do, I can plug in a, excuse me, I can plug in another point. So I can use either this one or this one and solve for b. Or I can put it in point slope form and distribute. So I might actually do that. Yeah, I'm gonna do that, you guys. Okay, so I'm gonna put in this point, 6, 0. So I'm going to treat it as equals for right now. So I have 0 is the y, equals -5/3 times 6. 6 is the x, and then plus b. So we're trying to solve for b here. So 6 times 5/3 is -10. So then add the 10 over, so 10 is equal to b. So then I can put in my y-intercept here. Now you'll notice the shading doesn't go beyond the x and y axis. So those are actually the constraints we saw up above this guy. X is greater than or equal to 0 and y is greater than or equal to 0 because, so probably should have made my curly brackets more elongated to include those. Okay, so it is above the x-axis, so that's y is greater than or equal to 0, and it's right of the y-axis, so that's greater than or equal to 0 for x as well. So if the shading continued beyond those, I wouldn't need those two components, but if it stays in quadrant 1, those two are part of it as well. Okay, that is all for this video. Thanks for watching.